The frequency of a stretched string depends upon the tension F, length L of the string, and the mass per unit length mu of the string. Derive the formula for frequency. Let F proportional to the F to the power A into L to the power B into mu to the power C. So we have F equals to K into F to the power A into L to the power B into mu to the power C, where K is a dimensionless proportionality constant. Now writing dimensionally above formula, dimensionally F equals to dimensionally F to the power A dimension into dimensionally L to the power B into dimensionally mu to the power C. This implies dimensionally T to the power minus 1 equals to dimensionally M into L into T to the power minus 2 to the whole power A into L to the power B into M into L to the power minus 1 to the whole power C. This implies M0 L0 T minus 1 equals to M to the power A plus C into L to the power A plus B minus C into T to the power minus 2A. So equating the powers on both sides, we get A plus C equals to 0, equation 1, A plus B minus C equals to 0, equation 2, minus 2A equals to minus 1, equation 3, from 3A equals to 1 by 2, equation 4. Now from 1 C equals to minus A equals to minus 1 by 2, equation 5. Hence from 2 B equals to C minus A, minus 1 by 2 minus 1 by 2 equals to minus 1. Thus A equals to 1 by 2, B equals to minus 1, and C equals to minus 1 by 2. Now we can write F equals to K into F to the power A, L to the power B, mu to the power C equals to K into F to the power 1 by 2, L to the power minus 1, mu to the power minus 1 by 2, or equals to K into F to the power 1 by 2 by L into mu to the power 1 by 2, or F equals to K by L under root F by mu. And experimentally we have the value of K equals to 1 by 2. Hence frequency F is given by 1 by 2L under root F by mu. Answer. In the gas equation, under bracket P plus A by V square into under bracket V minus B equals to R theta, where theta is absolute temperature, P is pressure, and V is the volume. What are dimension of constants A and B? To solve this problem, we use the principle of homogeneity. So from the principle of homogeneity, we can write dimension of B must be equal to the dimension of B. So dimension of B equals to dimension of B. Writing dimensional formula for B. Hence dimensional B equals to dimensional B. Now dimensional B equals to L to the power 3. So dimension of B is LQ. Now dimension of A by V square equals to dimension of P. Hence dimensionally A by V square equals to dimensionally P. This implies dimensionally A equals to dimensionally P into dimensionally V square. So putting value of dimensional formula of P and V, we get M into L to the power minus 1 into T to the power minus 2 into L to the power 6 equals to M into L to the power 5 into T to the power minus 2. Answer. Question. Pressure P varies as P equals to alpha by beta exponential minus alpha Z by Kp into theta, where Z denotes the distance, K beta is Boltzmann's constant, theta is absolute temperature, and alpha beta are constant. Find dimension of beta. Solution. We know that power of exponent is a dimensionless number. So hence alpha Z by k beta into theta equals to m0 l0 t0 or alpha equals to m0 l0 t0 into dimensionally k beta into theta by z or m0 l0 t0 equals to ml2 t minus 2 by l equals to mlt minus 2. Here we have put the dimensional formula of k beta, theta and z. Now dimension of alpha by beta equals to dimension of p. Hence dimension of beta equals to dimension of alpha by dimension of p. So putting the value of dimension of alpha and dimension of p, we have dimension of beta equals to ml t minus 2 by ml minus 1 t minus 2 equals to m0 l2 t0. Answer. Limitation of dimensional analysis. First, the method of dimensional analysis does not give any information about the constant k. 2. It fails to derive the relation if any quantity depends on more than fundamental quantities. That is in mechanics 3 fundamental quantities. Example, capillary rise h equals to 2 into t cos theta by r rho g. Here h depends on 4 quantities of mechanics. We have only 3 equations. See, it fails to derive the relation like s equals to ut plus half at square. Mean equation in which there is summation and subtraction type of terms. Fourth, the method fails to derive relationship which involves trigonometric, logarithmic or exponential functions. Taking force, length and time to be the fundamental quantities, find the dimension of density, pressure, momentum and energy. Solution. A. We have dimensionally f equals to mlt minus 2, equation 1. Dimensionally t equals to t, equation 2, and dimensionally x equals to l, equation 3. Hence density m into l to the power minus 3 or m equals to f by l into t to the power minus 2 or f into l to the power minus 1 t to the power minus 2, equation 4. Hence density, dimensionally density f into l to the power minus 1 t to the power 2 into l to the power minus 3 equals to f into l to the power minus 4 t to the power 2. Again B, pressure, dimensionally pressure equals to dimensionally force by dimensionally area. So dimensionally f by dimensionally L2 or f L minus 2. Again C, momentum, dimensionally momentum equals to dimensionally mass into velocity equals to dimensionally mass गुने dimensionally velocity. The m into l into t to the power minus 1 and equals to f l minus 1 t2 into l t minus to the power minus 1 equals to f into t. Hence D, energy, dimensionally energy equals to m into l to the power 2 into t to the power minus 2. Using the value of m, f l to the power minus 1 t to the power 2 into l square t to the power minus 2 equals to f into l. Suppose the acceleration due to gravity at a place is 10 meter per second. Find its value in centimeter per minute square. Here dimensionally a equals to l into t to the power minus 2. Acceleration equals to l t to the power minus 2. Now we have n2 equals to n1 into. Now n2 equals to n1 into dimensionally l t minus 2. So L1 by dimensional L1 by L2 into t1 by 2 to the power minus 2 or equals to n1 to L1 by L2 into T2 by T1 to the whole square. Now we have n1 equals to 10 into L1 equals to 1 meter and L2 equals to 1 cm into 1 minute by second whole square. Solving this, we get 10 to the power 3 into 3600 or 36 into 10 to the power 5. So the acceleration in terms of, so the answer will be 36 into 10 to the power 5 centimeter per minute square. Answer. Hence A equals 36 into 10 to the power 5 cm per minute square. Question. The average speed of a snail is 0.020 miles per hour and that of leopard is 70 miles per hour. Convert these speeds in SI. V equals to LT minus 1 dimensionally. So for a snail, L2 equals to N2 equals to N1, L1 by L2 into T1 by T to the power minus 1 equals to N1 into L1 by L2 into T2 by T1. Putting all values 0.020 into 4 miles by meter गुने second by hour. Solving and using all values we get 0.00893 meter per second. For leopard, N2 equals to N1 into L1 by L2 into T2 by T1. Using all values, given values, we get 31.2 meter per second. Question. The height of mercury column in a barometer in a Calcutta laboratory was recorded to be 75 centimeter. Calculate this pressure in SI and CGS using the following data. A specific gravity of mercury is 13.6. Density of water 10 to the power 3 kg per meter cube. And G equal to 9.8 meter per second square at Calcutta. Pressure equals to H rho G in usual symbols. We have P equals to H rho G. In SI, P equals to 75 by 100 meter into 30.6 into 10 to the power 3 kg per meter cube into 9.8 meter per second square. Solving, we get 9.9 into 10 to the power 4 Newton per meter square, or equivalent to 10 into 10 to the power 4 Newton per meter square. A specific gravity of mercury, density of mercury divided by density of water. Hence density of mercury बराबर specific gravity of mercury गुने density of water 3.6 into 10 to the power 3 kg per meter cube. In CGS, dimensional P equals to M into L minus 1 T minus 2. Hence now N2 equals to N1 by U1 by U2. N1 by M1 by N2, L1 by L2 to the power minus 1, T1 by T2 to the power minus 2 equals to N1 into M1 by M2, L2 by L1, T2 by T1 to the power square, power 2. 10 into 10 to the power 4 kg by gram, cm by meter, second by second. Solving, we get 10 into 10 to the power 5 and the unit of second is dyne per cm square. So answer will be 10 into 10 to the power 5 dyne per centimeter square. Express the power of 100 watt bulb in CGS unit. Dimensionally power equals to ML2 T minus 3 T to the power minus 3. So N2 equals to N1 into M1 by M2 L1 by L2 का whole square T1 by T2 to the power minus 3. Using the all values 100 गुने kg by g meter by cm का whole square second by second का cube. Solving, we get 10 to the power 9. Hence in CGS power equals to 10 to the power 9 org per second. Question. The surface tension of water is 72 dyne per centimeter. Convert it in SI unit. We have formula for surface tension equals to F by L. Hence dimensionally surface tension equals to MLT minus 2 by L MT minus 2. So now use formula N2 equals to N1 into U1 by U2, N1 into M1 by M2 into T1 by 2 to the power minus 2. So 72 gram by kg into second by second to the power 2. 72 into gram by 1000 gram 72 10 to the power minus 3. So answer will be 0.02 Newton per meter. Question: the kinetic energy K of a rotating body depends on its moment of inertia I and its angular speed omega, assuming the relation to be K equals to small k into I to the power A into omega to the power B, where small k is a dimensionless constant. Find A and B. Moment of inertia of a sphere about its diameter is 2 by 5 m/r square. Given k equals to k into I to the power A omega to the power B. So dimensionally k equals to I to the power A into omega to the power B, or m L2 t minus 2 equals to m into L2 power 2 to the power A t to the power minus 1 to the power B, or m into L to the power 2 t to the power minus 2 equals to m to the power A L to the power 2a t to the power minus B. Equating the power of mlt on both sides, we get A equals to 1, 2a equals to 2 and minus 2 equals to minus B. Hence A equals to 1 and B equals to 2. Theory of relativity reveals that mass can be converted into energy. The energy so obtained is proportional to certain powers of mass and the speed c of light. Guess a relation among the quantities using the method of dimension. Since let E proportional to the m to the power A into c to the power B, where m is the mass and c is the velocity. This implies E equals to k into m to the power A into c to the power B, where k is a dimensionless proportionality constant. So dimensionally E equals to m to the power A, dimensionally m to the power A, dimensionally c to the power B. This implies m into L to the power 2 t to the power minus 2 equals to m to the power A, dimensionally L into t to the power minus 1 to the power B, m to the power A equals to m to the power A L to the power B into t to the power minus B. Equating the powers of m, L and t, we get A equals to 1, B equals to 2 and minus B equals to minus 2. Hence A equals to 1 and B equals to 2. Hence above formula becomes E equal to K into MC square. Answer.